derivative. I'm going to copy it again so I can have it in front of us here. So the first derivative, I'm going to write it as 2x plus 1 to simplify it. So x squared plus 2x plus 5. We're running a clean ship here. So this is x plus 1 over the square root of x squared plus 2x plus 5. So I'm going to plug in a number like -5, and then I'm going to plug in 0 to study the sign left and right of its x-intercept if you want. But it's not the x-intercept of the function. I'm talking about the derivative. What type of number will this always be?
Positive.
Very good. So in that case, I don't care to waste my time on it. So in the numerator, please plug in -10 and tell me the sign, and plug in 0 and tell me the sign.
It would be negative for -10. And positive for -1.
Perfect. So now this is the moment of truth. This is when I catch my mistakes. Okay. So what does the function do here? Between -infinity and -1, what should the function do if its derivative is negative?
Decrease.
Perfect. Is it decreasing from infinity to 2?
Yeah.
Perfect. What should the function do between -1 and infinity since its derivative is positive?
Increase.
Is the function increasing from 2 to infinity?
Yes.
Good. So then the function is increasing decreasing from -infinity to -1. So f decreasing on -infinity, -1, and f increasing on -1 to infinity. Now let's analyze this point. Look at the derivatives, or derivative. Negative here, whatever, 0 at this point, and then positive. What type of point is -1, 2? I couldn't hear you. Very good. So -1, 2 is indeed a relative min. Because the derivative of the function, or if you want, the function is decreasing till this point and increasing afterwards. So this must be a relative minimum. Very good. Okay. I want to look at right. Let's look at 88, and then I'll stop. It's a word problem in this section on page 202.
There's no maximum?
I'm sorry?
There's no maximum?
What about this function? Does this function have to have a relative min and a relative max?
No.
It doesn't have to have any. Look at this function. How many max min does this function have?
None.
None. Yep. So we have a function n of a, which is -a squared plus 300a and plus 6. And a is a number in 0 to 300. So there, do I still have time? Yeah, I have time. Good. So they're asking us to, how many units should we sell for a maximum profit? Is it profit? Advertising? Yeah. So how much is A for a maximum? Find A that gives a max n of A. This is our question. What do I have to do first?
State the domain.
Very good. But we are excellent, but we are already given the domain. For this particular function, we are given 0 to 300. We have to use 0 to 300. Perfect. Okay. Next, what do I need to determine?
The derivative.
Find the critical number.
Very good. Excellent. In order to find the critical number, we start with the derivative. Awesome. Great job. Can anyone give us the derivative?
Negative
What is
2a plus 300.
Negative 2a plus 300.
Very good. Good. Remember, critical numbers come from two sources, from n prime of a being undefined. Is that a possibility?
No, it's a polynomial.
It's a polynomial. So what about n prime of a being 0? Like negative 2a plus 300 equals 0 and a equals?
Negative, nope, 150.
Very good. Perfect. So now I get my table going immediately. So here it is. I don't know what page I'm on. I think it's 10. Okay, I have a. Yes, the domain is crucial, but I already have it. It's fixed, 0 to 300. I can change that. The next in line is negative n prime of a, and the next one is n of a. Is 150 in the domain? Yes, it is. What do I write here in the row for n prime?
0.
Of course. I'm going to copy so I can move this away. So remember, n prime of a equals negative 2a plus 300. I need someone to give me the solutions. I mean the sign. And in the meantime, we have to plug in this function. We have to plug in 150. So negative in front, negative 150 squared, and then plus 300 times 150, and plus 6. I got 22506. Correct me if I'm wrong. Negative 150, that's correct. 300 times 150, yes, plus 6. 22506. Okay? So I need the sign.
0 should be positive, and 300 should be negative.
So on this side, when you plug in 0, it's positive. Very good. And when you plug in 300, it has to be negative. Very good. Now in the function, when I plug in 0, 0, 0, I get 6. I also have to plug in 300, but what I'm going to do, I'm just going to recall this because I'm lazy and just do it again with 300. So I'm just changing to get that 6.
How did you do that on the calculator?
Yeah, let me show you that because it's important. Let me show you, and let me share my screen. Yeah, let me show you that. It's difficult to see. I was just doing it quickly. Okay, I'm sharing my screen. Please click and see whatever it gives me. Okay, good. So I wrote this, negative 150 squared initially times 300. I was, where's my calculator? Yes, so times, plus, no, not times, plus 300 times 150, and then plus 6. And then I copied second and entry, and I overwrote 300. I overwrote 150 by 300. So that's it. So I don't have to type it up again. This is not that long, so that's not a big deal, but in general I do that so I don't have to type it again. I may make an error. It's possible. Okay, so this is 0. This was not 0, this was 6. And this is 6 as well in the function. Yeah, good. So now we established the sign of the derivative. So what does the function do here when the derivative is positive?
Increases.
Is it increasing from 6 to 22,506?
Yeah.
And is it decreasing back to 6? Yes. What type of point is this? What type of point is, yes, 22506. Obviously, because the derivative does this. First, the derivative or the slope of the tangent to the graph of the function is positive. It reaches 0, horizontal tangent, and then negative. So this is indeed a relative max. It also, for this function, it happens to be also the absolute max, not just the relative.